Hello students, in this video we'll discuss how to compute the distance between a plane and a point, in particular the distance between a plane and the origin. Let's consider the symmetric form of a plane. AX plus BY plus CZ is equal to D. And let's look at a special case of this. A special case of this occurs when D equals 0. If D is equal to 0, the equation of the line becomes AX plus BY plus CZ is equal to 0. And this tells you that the origin is on the plane. So when the right-hand side is equal to 0, the origin is on the plane. Let's now consider if D is not 0. Then what we have is the following. We have the equation of the plane. Here's our plane. And then here's our normal vector to the plane. That's our vector A, B, C. So that's going to be our normal vector. And so now, of course, we're in the situation where AX plus BY plus CZ is equal to D. That's our equation of our plane. And we know that if I plug in 0, 0, 0, that the origin is not on the plane. So let's assume the origin's over here. There's the origin, 0, 0, 0. And what we want to do is we want to find the distance from the origin to the plane. So we want to find the point on the plane right over here. Let's call that point over here P, a point on the plane. And I want this to make a 90-degree angle with respect to the plane. So I want to find that distance. What we can do is we can find another arbitrary point in the plane. Let's call this arbitrary point in the plane over here R. And what do we know? The vector R is a point on the plane, so it will satisfy this equation over here. X, Y, and Z will satisfy this equation. And what we'll do is I would like to find the projection. So this vector over here, this distance from 0 to the origin, is in the same direction as the vector A, B, C, which is the normal vector. So what we'd like to do is we'd like to project our vector R onto this vector A, B, C. So the projection of the vector R onto A, B, C is going to give us the distance. The magnitude of this projection is the distance from the origin to the plane. Now we know the formula for the projection. The projection of R onto A, B, C will be R dot A, B, C, the length of that, over the length of A, B, C, A squared plus B squared plus C squared. And so what we have over here is this is going to be R dot A, B, C. Well, this equation in the plane over here is really R dot A, B, C is equal to D. So we see that this would be D over the square root of A squared plus B squared plus C squared. And so in particular what this says is we should make a remark about this. If you have a unit normal vector n hat dot R is equal to 0, is equal to D, the equation of a plane, then if this is a unit vector, then the right-hand side is the distance from 0, 0, 0 to the plane. If it's not a unit vector, we have to divide. I put absolute value there. We have to divide by the what? We have to divide by the length of the normal vector that is on the left-hand side of the equation. Thank you very much.